Hello, scholars. First of all, sorry if the quality of this video is not quite as good as usual because I forgot my stuff at home, and so I'm using Miss Crowley's document camera. But should still work. You should still be able to get the idea of what we're doing. Today we're working on Chapter 7, Section 5. So we've been working really hard over the last couple weeks on exponents, exponent rules. What if I have a fraction in an exponent? What if I need to solve a solution with a variable in an exponent? Now we're going to talk, what this is all kind of leading up to is exponential functions. I think the core thing that we've really got to take away from this chapter. And so our objective is nice and simple for today. It says I can identify and graph exponential functions. So I want you to be able to do these two things. I need you to be able to identify an exponential function given a table, graph, equation, etc. And I need you to be able to graph my exponential function. So let's dive into it. So given a table, it should be fairly easy to figure out if something is exponential or not, okay? Because if I am doing something exponentially, it means I'm multiplying or dividing by some number every time. Let's write that. We're looking for multiplication or division every time, right? And we could just say the word multiplication because we could think of our division as just multiplying by a fraction, right? Because really what we're saying is that anything exponential is gonna be some like base number. I'm gonna call that b to some x. So if, for instance, I put a 2 right here, I would be doing, if it was 2 to the first, I would have 2. If it was 2 to the second, I'd have 4. If it was 2 to the third, I'd have 2 times 2 times 2. 2 to the fourth, I would have 2 times 2 times 2 times 2. We're just multiplying by this same number one more every time we add to our x here. So let's take a look. Some of these should jump out and you should be able to say, oh, that's not linear. So, or that's linear, or that's some other thing. Okay, so, I mean, we're obviously adding 5 here every time, right? So I hope that you already have written down that this thing is linear because we are adding 5 every time. Let's look at number 2. What are we doing every time? Well, I see times 3, times 3, times 3. So we're just asking ourselves, am I adding, subtracting, multiplying, or dividing every time? If it's multiplication or division, it is exponential. Exponential. And if you want to write down here a note for yourself multiplying by 3 every time, feel free. Okay, what is happening here? Well, just take a second and look and see what's happening. It looks like I'm dividing by 2. Dividing by 2. I'm going to say I'm multiplying by 1/2. Because I like to think of exponentials as always multiplication. Because that, I think, makes it easier to write equations eventually. Exponential. Okay, I'm going up by nothing, nothing, nothing. I hope you say that this is a horizontal line. Y is always 3, so this is linear, not exponential. Number 5, what are we doing? Well, it looks like I'm times 1/2. Times 1/2. times 1/2. We are exponential again. Same thing as this one, right? It's like we're further. And we got to be careful too. We're actually doing something much smaller, aren't we? Because this is counting by 5s. This is counting by 2s, so we would need to take that in consideration. But all I want you to be able to do right now is figure out if it's exponential or linear. Finally, what are we doing? Oh, it looks like we're multiplying times 1/3, times 1/3, times 1/3. We are exponential again. So those are just some examples of how you can identify whether something is exponential or not, or linear, or we'll throw quadratic in there soon. Okay, on to this side. So graphing things that are exponential. Now, I think the easiest way to do this is to pick some smart points, and I noticed that all 3 of these aren't moved left and right, so I am always just going to do this. I'm going to put an x and a y here, and I'm going to put -2, -1, 0, 1, and 2. I want to see what's happening just a little bit to the left and a little bit to the right of my y-axis here. So now this is fairly easy. I'm going to draw a note over here. This is, if I plug in -2 up here, I get 3 to the -2. Why did we spend so many chapters on exponent rules, etc.? Well, I needed to know, for instance, that this is this. Yeah, when I have a negative exponent, I write it as 1 over that number with a positive exponent. And 3 times 3 is 1/9. Now, if I put -1 in here, again, I've got 3 to the -1, which just equals 1 over 3 to the first, which is 1/3. If I put 0 up here, if I have an exponent that is 0, another exponent rule, we know that that thing equals 1. This y-intercept, unless it's moved up or down, you are always going to have a 0.01, okay? If you have a base form exponential function, okay? And we're going to talk about what those base forms are here soon. But if I just have a number to an exponent, I'm always going to have this point. If I put a 1 up here, 3 to the first power is 3. If I put a 2 up here, 3 times 3 is 9. Now I can plot some points. I've got my y-intercept. I've got 1, 3. I've got 2, 4, 5, 6, 7, 8, 9. And this is like where 1/3 is. And now we're getting really close to that x-axis. We're going to talk about this in a second, but this is never going to cross the x-axis. And if you look at this, you're going to see why. This is always going to be, no matter how small this exponent gets, it's always going to be 1 over some number, which is always bigger than 1, right? So it's never going to cross this x-axis. It's just going to keep getting really, 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 really close to it. Okay, let's do it again. X and Y. Feel free to like pause the video or just ignore me for a second and do this on your own, and then come back to it and see how you did. So I've got, if I put a -2 here, what do? That flips this, right? So this becomes 3 squared. So I've got 9 plus 1 more is 10. This is going to flip it again. I'm going to have 1/3 to the -1. Well, that just equals 3 to the first, right? So 3 plus 1 is 4. Now I'm going to get my fractions. If I put a 0 here, anything to the 0 power is 1. 1 plus 1 is 2. Why do I have 0, 2 instead of 0, 1? Well, because I moved my function up 1. Still thinking about this number as a transformation. It is moving our function up 1 spot. If I put a 1 in here, I've got 1/3 plus 1. Well, that's 4/3. If I put a 2 in here, well, that becomes 1/9. So I've got 10/9 when I add that to 1. And now I am plotting my points here. I've got 0, 2. Notice that it's counting by 2's here. They put a 2 right there for us. -2, 10. So 2, 4, 6, 8, 10. 4. And then we're at just a little bit over 1. That's got to be just above halfway there. And still just a little bit over 1. This is, again, it is not going to cross, not the x-axis this time, but it's not going to cross the number 1, right? Because we've moved this up 1 spot. So another thing we're going to talk about, but there's an asymptote here that it never crosses, okay, at y equals 1. Okay, same thing here, -2, -1, 0, 1, and 2. I'm going to plug in -2 here. That is going to flip this 1/2 to the -2. Well, that equals 2 to the 2. So 2 times 2 is 4, minus 2. 4 minus 2 gives me 2. Same thing, 1/2 to the -1 equals just 2 to the 1. So 2 minus 2, that gives me 0. And then if I put a 0 in here, anything to the 0 power equals 1 minus 2 is -1. If I put a 1 in here, 1/2 minus 2 is -3/2. And finally, if I put a 2 in here, 1/4 minus 2, what is that? -7/4. Yeah. Okay. So let's plot some points. We've got -2, 2. I've got -1, 0. I've got 0, -1. There's my y-intercept. And it makes sense, right? Where I expect to be is 0, 1, but I've moved down 2 units, right? So now my y-intercept is here. 1, -3/2, and 1, or 2, -7/4. So we are doing something like this. And what is my asymptote now? The line that this never is going to cross, well, it is now -2 is where it is never going to cross. So let's sum things up. I hope that I can give you any table and you can figure out if it's exponential or linear. I hope that I can give you any equation, you can graph it. Maybe I could even give you an equation and you're going to at least be able to tell me this about it. You might be able to tell me exactly what its equation is. Eventually you will be able to. But I need you to know these few things here. So let's take a look at this. I'm showing you 2 exponential functions and the form of y equals a to the x power. I said it slightly differently on the earlier page, and we're going to throw in a little bit more to this in a second. I would prefer that this was y equals b to the x, because eventually we're going to have y equals a b to the x power, where a is something we're multiplying this by. It's going to stretch this out, okay? But either way, we've got a base number to the xth power. In graph A, the value of A, this number that has an exponent that is a variable, that a variable exponent on it, this a is greater than 0, but it is less than 1. In the graph of a, the value of a is greater than 0, and less than 1. So this number right here, this is a fractional amount, right? So if I put 1/2, look what happens. All of a sudden we're going down from left to right. If I put a fraction, 1/3, we're going down. So this is a fractional amount between 0 and 1, and as the y value decreases, the x value increases. I would prefer that they said that the opposite way. I prefer that it said as the x value increases, I always think about my independent variable first. As x increases, my y is decreasing in value. In graph B, the value of a is greater than 1, and so the y value is increases as x value increases. So I think that's a decent summary of this, and I just wanted to kind of sum it up in a simple form, but I also included this, and you can't see it very well on the document camera, but this is, if you just flip back a couple pages, it was on the back of 7.4. And I just wanted to show you, again, this is an exponential growth function. We just talked about it here. An exponential growth function. It is increasing as we move from left to right. As x increases, y also increases. And I just wanted to give you a little more detailed explanation of this. If I ask you, for instance, the domain and range of this, you'll see that the domain is all real numbers. It's always going to be all real numbers for something that is exponential. And the range is from 0, greater than 0, to positive infinity, or all positive real numbers. Notice that intercepts, there's one y-intercept, no x-intercepts, because the x-intercept has become what we call an asymptote, meaning it's a line that this function can never cross or reach. We're talking about what's happening at the end behavior. So this is just a more detailed explanation of any exponential function. And then this is exponential decay, obviously decreasing from left to right. But same kind of ideas. You just notice it's been flipped around. So like I said, I want you to be able to identify, do we have exponential growth or decay? I want you to be able to identify, if I give you a table, is it exponential? And you be able to graph any exponential function. Let me know if you have any questions, and we will get to working on this soon.